All right, if you're just joining us, we are on question number 4 for the Unit 5 review, Unit 5 chapter review on particles too small to measure. Now for question 4, we're going to be going back and forth between grams to moles versus moles to grams. And you'll notice that the first 3, we are given the grams, we want to find the number of moles. And for the next 3, we're given the number of moles, we want to find grams. So we're using the same skill, just kind of a couple different ways of looking at it. Now, in our first example, we were given 12 grams of iron. So we always want to start by writing our given over 1, 12 grams of iron over 1. And then we want to multiply that then by our molar mass. So when I look over here on the periodic table, I see that my molar mass for iron is 55.85. So I'm going to bring that in here. 55.85 grams of iron for 1 mole of iron. Very important that we're showing all of our work, showing all of our units in our work as well. And so from here we do the math. So we have 12 divided by 55.85 equals. Now I don't want to go through this too quickly because one thing we want to remember is we want to multiply across the top, multiply across the bottom, and then divide. So multiplying across the top, I have 12. Multiplying across the bottom, I have 55.85, and then divide. And so I don't want to go through that part too quickly without explaining sort of what we are doing. So we end up with 0.21, I'm going to round that up and say 215 moles of iron. Now for question 2, it tells us that we have chlorine gas. Now hopefully you remember from earlier, from question 1, that chlorine, when it's by itself, is actually diatomic. That's one of the diatomic elements that we had in our list from earlier. So let's go ahead and start with our given over 1, 25.0 grams of chlorine over 1. And now we're going to multiply that by our molar mass of chlorine. Now on the periodic table, we see that chlorine is 35.45, but remember it's diatomic, so we need to double that. 35.45 times 2 gives us about 70.9. So that's going to be our molar mass for chlorine gas. 70.9 grams of chlorine for every 1 mole of chlorine. And now we do the math. Again, multiply across the top, multiply across the bottom, and divide. So I'm going to go ahead and jump straight to the divide part. A little bit of a shortcut there. And we end up with 0.3526, looks like 1. So I'm going to round that to 0.352 moles of chlorine gas. And then one last one here for this sample, we're given a much more complex compound. Now, as we did before, we want to make sure that we determine everything inside the compound to find the molar mass. So we've got 4 as a multiplier for hydrogen. So inside the parentheses, we have 1 nitrogen and 4 hydrogen. But all of this has a multiplier of 2. So that actually gives us 2 nitrogen, 4 hydrogen. Here we have 1 sulfur and 4 oxygen. So going through all of that, calculating it up, we're going to use that entire molar mass. So 0.476 grams, and I'm not going to write out the entire formula for this one in this case. Works out to, I did the math earlier, about 132.1 grams for 1 mole. So doing that calculation, kind of multiplying it across, let's see, we have a very small number, that's for sure. 0.476, divide that by 132.1 will give us 0.0036. So that works out to about 0.00. We'll round that and say 4. Now you could also turn this into scientific notation, in which case it would be 4.0 times 10 to the negative 3, or actually it would probably be more accurate to say 3.6 times 10 to the negative 3. Either of those would be fine. Any of those would be just fine. All right, now, letter D, we're actually given the number of moles, and from the number of moles, we want to find the mass. So again, we'll still need to use the molar mass. So for letter D, we're going to start with 0.15 moles of NaNO3. And then we're going to multiply that by the molar mass. Now to find the molar mass, you'll again use your periodic table and see that sodium, we have 1 sodium, we have 1 nitrogen, and we have 3 oxygen. Adding all of those up gives us 85.0 grams for 1 mole. Now notice how we have this set up. In the first 3 examples, we had moles over grams, moles over grams, moles over grams. Now we switch it to grams over moles. Remember, we do want to make sure that we are using our units so they can cancel out. Moles will cancel moles, leaving us with grams, which is what we want. And so paying attention to your units, we can know how we're going to set up the calculation. So 0.15 times 85 gives us 12.75. So we'll have 12.75 grams. Letter E, we have 0.028 moles of NO2, 0.028 moles over 1. And then from using our periodic table, we see we have about 46 grams of NO2 for 1 mole of NO2. And multiplying across, we end up with about 1.29 grams. And then finally, our last one, aluminum chloride. Now, they give us the formula, they give us the name, but they don't give us the formula. And I'll just tell you right now, it's AlCl3. So you have 3 chlorines with 1 aluminum. So 0.64 moles of AlCl3. And then we're going to multiply that by the molar mass of aluminum chloride, which is 133.5 grams of AlCl3 for 1 mole. And we end up with about 85.4. So that's 85.4 grams of aluminum chloride. Hope that helps. Please let me know if you have any questions.